I'm politically your maths teacher. Today I am going to start exercise 3.1 sub number 2, that is the chapter name is coordinate geometry. Previous day I have solved question number 1. Today I will solve question number 1. Student, I have not written that statement of question number 2 because it is a long question. Whenever you are going to solve this question, please follow the book. Okay, just I read the question and I divide the question part by part, then I solve the question. A city has two main roads which cross each other at the center of the city. Okay, these two roads are along north-south direction and east-west direction. Okay, this sums about the roads of a city, that the main roads are in north-south direction. Okay, so we have, that is north direction, south direction, west direction and east direction. Okay, so take a road along north-south direction. Okay, now and another road is east-west direction. Okay, that is the first part. I have done that a city has two main roads, north-south direction and east-west direction. Okay, next part. All other streets of the city are parallel to these roads 200 meter apart. 200 meter apart. These are about five streets in each direction. Each direction means that in direction of parallel to north south, the city has 5 roads of 200 meter apart. I am taking 5 roads parallel to north south. 1, 2, 3, 4 and 5. Each are 200 meter apart. Okay. Now these are parallel. These roads are parallel to north-south direction and 5 roads parallel to east-west direction. 1, 2, 3, 4 and 5. These 5 roads are parallel to east-west direction. Okay, and that these roads are also distance between this main road and first road 200 meter. Okay, I am taking this one as 1, 2, 3, 4, 5. And each distances are equal. Okay, these distances are equal between these two. These are all equal. And 1, 2, 3, 4, 5. These are also equal. And so our scale is at 1 centimeter equal to 200 meter. Okay. Next, draw the model. This is a road model of the city, and question asked in the question number 2, that is there are many road streets under this model. Particular cross street is made of 2 streets, one running north-south and another east-west direction. It means cross street means this one. This is the cross point of north-south and east-west. These are the cross street. Okay, and each cross street refers the following manners if second street running in north south, second street of north south, it means this one, This one is the second road in the direction of north south. This one, and fifth in east west. Fifth in east west means 1, 2, 3, 4. Fifth in east west. This one. Okay. So in this part, two roads are mentioned. The first roads, the road number 2 in north-south direction, and road number 5, that is east-west direction. This combination of these two meets at that point. Okay, this is that is, and its name is, it is denoted as 2,5. Okay, 2,5 means number 2 and in north-south direction, and this road is 5th number road along east-west direction. This cross street will be denoted in this manner. Okay, and using this convention, with the same convention, how many cross streets can be referred as 4-3? How many cross street can be 4-3? Okay, 4-3. That was 4 means that is in north-south direction, and second one is east-west direction. Okay, so north-south direction, road 4, this one. Okay, and road 3 east-west, that is this one. The cross street, this is the meeting point of the road, 4th number road of north-south, and 3rd road of in the direction east-west. That is denoted as, okay, so meeting point of 4th road parallel to north-south direction and east-west direction, that is that cross street. Okay, now next question, how many cross street can we refer as 3,4? 3,4. This road along north-south, this road along east-west. So 3rd road along north-south and 4th road along east-west, this one. So meeting point of or cross point of these two street is this one, that is 3,4. Okay, so meeting 3,4 is only one cross street, and 4,3 is another. So we can conclude that in quadrant geometry 3,4 is not equal to 4,3. These two are not equal. Okay, in this way we have solved this question, and remember that all the distances, that is 1, 2, 3, 4 are equal, and whenever you are going to solve this question, please take the help of graph paper. Using graph paper you will solve this question. Okay, question number 1 of exercise 3.2. So first question of exercise 3.2, that is given, what is the name of the horizontal and vertical lines to determine the position in the coordinate plane? Coordinate plane, coordinate geometry means that two lines, that is horizontal line. In the previous class we have discussed on that is x dash, that is horizontal line, and vertical line, this one, that is y dash. Okay, these two lines, using these two lines in Cartesian plane, we identify the position of any point. These two lines are called, this horizontal lines is called x-axis, and vertical lines is called y-axis. Okay, so lines are called x-axis and y-axis. Next question, what is the name of each part formed by these two lines? That Cartesian plane is divided by these two lines, and these two lines divide the Cartesian plane into 4 parts. 1, 2, 3, 4. 4 parts. Okay, and 4 equal parts. All these parts are equal. So this part is called, first part, that is positive direction of x-axis and positive direction of y-axis, is called first quadrant. First quadrant. Negative x-axis, positive y-axis, second quadrant. Third quadrant, and this one is fourth quadrant. Okay, so these two lines divide the Cartesian plane into 4 parts. Each parts are called quadrant, and all parts are equal. And this one quadrant equal to any among these 4, any quadrant equal to 1/4 of Cartesian plane. Okay, Cartesian plane. Next question, write the name of the point where two lines intersect. These two lines, that is y-axis and x-axis, these are the lines intersect at a point, at a single point. We have to say the name of that point. This is our required point, that is called origin. That is called origin. And in the previous class I have discussed that what is the coordinate of origin, that is 0, 0. Another point, if any we have to calculate or identify any position of any coordinate of any point, we should start from the origin. Okay, that is the origin, that point name is origin, and the coordinate of the origin 0, 0. It means 0, 0 means distance from the x-axis, y-axis 0, distance from the x-axis 0. That's why it is 0, 0. That is second sum of exercise 3.2, question number 2. Okay, in this question a figure is drawn on your book, that I am trying to draw that figure. Okay, like this, and there are some points are there, like as B, C, D, E, F, E, H, and total 8 number of points. Okay, now some questions are asked in the question. First question is coordinate of B. Coordinate of B means that point. Okay, coordinate of B means that point. As we know, for plotting any point, we should start from origin, that is O point. First, we should go along x-axis, then y-axis. So, to reach that point, we should go along this negative x-axis. So 1, 2, 3, 4, 5, and 1, 2. So that point is minus 5, 2. Minus 5, 2. So coordinate of, what is the coordinate of B? That is minus 5, 2. It means perpendicular distance from x-axis, that is 2, and perpendicular distance from y-axis, that is 5. Okay, this distance is 5 unit. This distance is 5 unit, and this distance is 2 unit. Next question. Coordinate of C. Where is C point? That one. Okay. So first move along the x-axis. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, minus 5. So that point is minus 5. As it is lower portion of x-axis, so the measurement of y-axis is negative, that's why that is minus 5, minus 5. Next one, identify the point minus 3, minus 5. Minus 3 and minus 5 means lower parts of the x-axis. This one, that point is minus 3, minus 5. This is point E. Next, abscissa of D. Abscissa means x and y. Any coordinate consists of 2 points. That is two coordinate. That is x and y. It is called abscissa. It is called ordinate. Like as minus 3, minus 5. That point is E. Okay. What is the coordinate of abscissa of point E? That is minus 3. Okay. Next question is What is the abscissa of D? Where is D point? That one. First, we plot the point, that is 6, 2. That is 6, 2. So what is the abscissa? Abscissa is this coordinate, that is 6. Next question. Ordinate of H. H means 1, 2, 3, 4, 5 and 1. Okay, that question that is B 5 minus 2. Now ordinate of H. Ordinate of H means that point minus 5 minus 3. First part is abscissa, second part is ordinate. So ordinate of H, that is minus 3. Next question. Coordinate of L. That point lies on y-axis. So any point, coordinate of any point which lies on y-axis, that should be first x abscissa will be 0 and that is 1, 2, 3, 4, 5. Okay, 0, 5. 0, 5 means as it lies on the positive y-axis. That's why 0, 5. Last part, coordinate of M. That point is M. Start from origin 1 to negative axis, negative x-axis 1, 2, 3. That is minus 3. And as it is lies on the x-axis, coordinate part should be 0. So what is the coordinate of point M? That is minus 3, 0. Okay, students. In this class I have solved question number 2. Next video I will start exercise 3.3. Till then, stay at home and keep watching all the videos of BMS. Thank you.